This video is on writing and graphing linear equations in standard form. Another form of an equation of a line is called standard form. It is written ax plus by equals c, where a, b, and c are integers, a is greater than 0, in other words a can't be negative, and both a and b do not equal 0. A could be 0, b could be 0, but not both at the same time. So for example, in the equation 4x minus 7y equals 3, a is equal to 4, a is the coefficient of x, b is equal to negative 7, b is the coefficient of y, and c is equal to 3. C is the constant term that's to the right of the equal sign. Oops. When a linear equation is written in standard form, it's relatively easy to find the x and the y-intercepts of the graph and use these to graph the equation. Recall that the y-intercept is where the graph crosses the y-axis. At this point, x is always equal to 0. In the same way, the x-intercept is where the graph crosses the x-axis, and at this point, y is always equal to 0. So let's take a look at this example. It says identify the x and y intercepts of the equation 5x minus 2y equals 10, and then use these intercepts to graph the equation. So basically what I want to do, I kind of like to start with a little table here. I want to know when x is 0, what is y, and what is x when y is equal to 0. So 0 is a really cool number because it makes things go away. So let's go ahead and start with this first one, and let's plug in a 0 for x into this equation. So I have 5 times 0 minus 2y equals 10. Well, basically that goes away, doesn't it? Because that's equal to 0. So now I'm solving for y, and I'll divide both sides by a negative 2. So y is equal to negative 5. So when x is 0, y is negative 5, and that's going to be my y-intercept is, oops, I forgot the negative there, is a negative 5. Now we'll do the same thing and plug in a 0 for y and figure out what x is. So 5x minus 2 times y, which is 0, equals negative 10. I'm sorry, not a negative 10, a positive 10. And again, this is 0, and that just goes away. So I have 5x equals 10, dividing both sides by 5. X is equal to 2. So when y is 0, x is 2, and that means that my x-intercept is 2. Now if I want to go ahead and graph these, I just put those points on the graph here. My y-intercept is negative 5. Let's see, 2, 4, 5, which is going to be this point right here. My x-intercept is 2, which is right there. And I just connect those 2 points. Let's take a look at another example here. This table below represents a student's distance from home. We need to do 3 things. Write an equation in standard form that represents this situation, identify the x and y intercepts and explain what they mean, and then graph the equation using the intercepts. So let's first write the equation in standard form. It's hard to just take these numbers, you can't just plug them into standard form. So I'm going to start with slope-intercept form because I know that. Well, looking at the graph, this point right here, that's my y-intercept. So that means that b is equal to 4. Okay. Now I need to find my slope. In order to find my slope, I'll just take any 2 points. I'll take the first 2 here, and I'll do 3 minus 4, 2 over 2 minus 0, and that gives me a negative 1 over 2. So my slope is a negative 1/2. That means my equation in slope-intercept form is y equals negative 1/2 x plus 4. But now I need to turn that into standard form. So remember, in standard form, the x and the y and their coefficients are on the left of the equal sign. So I'm going to add 1/2 x to each side. And that's going to give me 1/2 x plus y is equal to 4. And remember, a, b, and c, the coefficients of x, y, and the constant term have to be integers. They cannot be fractions. So I need to do a little fraction busting here, and I need to get rid of this 1/2. So I'm going to multiply the whole equation by 2, which is the denominator here, and distribute that 3 times to give me x plus 2y equals 8. So there's my answer to part A. There's my equation that represents this situation in standard form. Now I need to identify the x and the y-intercepts and explain what they mean. Well, I've already identified the y-intercept. My y-intercept is 4. So what does that mean? Well, it looks like when her time is 0, her distance is 4. So what that means is that her distance from home was 4 miles when she started. So when she started out, when Eva started out, she was 4 miles from home. Oops. Okay. My x-intercept is going to be this value right here because that's when my y equals 0. So my x-intercept is 8, and that means that her time was 8 minutes when her distance from home was 0. So what that means is it took her 8 minutes to get home. So it took Eva 8 minutes to get home. Okay. Now let's go ahead and graph this. So my y-intercept was 4, so that's going to be at 4 on the y-axis. My x-intercept was 8, which is going to be 8 on the x-axis. And now when I go to draw this, I'm just going to draw the line like that. I'm not going to make it a full-on line with arrows on the ends because remember, my x-coordinate, this was time. My y-coordinates were distance. And I can't have negative time and I can't have negative distance. So my graph is going to look like that. So here are a couple practice problems for you to try in your math journal. So I'm going to ask you to stop the video and do these two problems in your math journal, and I'll come back and do them for you in just a few minutes. Okay, so our first practice problem says to identify the x and y intercepts of 3x plus 4y equals negative 12 and use these intercepts to graph the equation. So I basically want to find out what is y when x is 0 and what is x when y is 0. So plugging in 0 for x, okay, that's going to give me y equals negative 3. And then plugging in 0 for y, dividing by 3, that's going to give me x equals negative 4. So my x-intercept is negative 4, and my y-intercept is negative 3. And I will graph negative 4 on the x-axis, negative 3 on the y-axis, and connect those with a line. Second practice problem says that the table below represents a scuba diver's depth. Write an equation in standard form to represent this situation, then identify the x and y intercepts and explain what they mean, and then graph the equation using the intercepts. So the first thing I'm going to notice is that right here I have my y-intercept, so my b is equal to negative 12, but I need to find my slope. So to find the slope I'm going to use any 2 points, so I'll just use the first two, negative 18 minus a negative 24 over 3 minus 0. That's going to give me 6 over 3, or my slope is equal to 2. Plugging those into y equals mx plus b gives me the equation y equals 2x minus 12. But I need to have this written in standard form, so I'm going to subtract 2x on each side. So 2x plus y equals negative 12. And my coefficient of x, can't be negative, so I'm going to multiply the whole equation by a negative 1, and that gives me 2x minus y equals a positive 12. So there's the answer to part A, the equation in standard form. My x and y intercepts, so my y-intercept is negative 24, And let's take a look at what that means. So when time is 0, the depth of the scuba diver is negative 24 meters. So that means when he starts to measure his time, probably when he starts his ascent, he is 24 meters below the surface. And that's when he's starting out. Okay, my x-intercept is this right here. My x-intercept is 12, and let's take a look at what that means. So that means when his time is 12 seconds, his depth is 0. So that means that it takes him 12 seconds to get to the surface. Sorry about that. It takes him 12 seconds to get to the surface. So he starts 24 meters below, and in 12 seconds he's at the surface. So let's go ahead and graph those. My graph only goes to 10, so I'm going to count by threes. Oops, oh dear. Hold on. There we go. Let's count by threes. Okay, so negative 24 is going to be 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 times 3 is negative 24. And then 12 is going to be here. And let's connect those points. So it's going to look like this. My graph is going to look like this. And I'm not going to go negative because his time can't be negative. Remember that my x is time. And my depth is here. And that actually can be negative, but it can't go any further. Well, actually, to be honest, the depth can't be positive because he's actually below the surface of the water, and it's not like he's being lifted up above the water by a helicopter or anything. So that's what my graph would look like. So in this video, we took a look at writing and graphing linear equations in standard form, which is ax plus by equals c.